Hi, today we'll be studying design patterns. Imagine a situation when you want to change a bit of your source code. Maybe because of boss, maybe because of the customer, or it may be because the team decides it. Now the source code has to be changed in such a way that the tiny source code changes. For example, the data serialization format, it may be JavaScript object notation, JSON, has to be changed to binary version, that is BSON. It is derived from JSON. Now, these small code changes inside your application will affect the entire code module. Worry about it. Many experienced software professionals have faced this problem, and from them we have come to the solution. The solution is design patterns. Now, imagine one more situation when you are yourself going through the code and you face certain object name changes inside this code. Now, once you do some changes, these changes will get affected to the source code. So, we have something known as shared vocabulary. What is shared vocabulary? How a design pattern can act as a shared vocabulary. Now, when there is one change at some point of code, and we should make sure from that change it should communicate to other parts of the code also. This type of communication is done by observer pattern. So, we have in total 23 design patterns which were invented by 4 software engineers. Now, we will not be studying all the 23 patterns, but from my way of teaching is Socrates way. What is the Socrates way of learning? It is by asking questions. So, we will be seeing one application, one live application about an electronic delivery app, electronic shop which is delivering electronic components online. So, from this I am assuming that you are familiar with somewhat object oriented programming concepts. I will be using C Sharp. C Sharp and Java are somewhat different in syntax and in terms of writing code, but if you are familiar with object oriented programming, these codes are enough readable. Okay. Now, coming to design patterns definition. So, design patterns are general solution to a commonly repeatable problem. They are not header files or they are not libraries which can be included in the code. Yes, libraries are kept. If libraries do use design patterns in order to write the codes inside libraries, but it does not mean that if you include libraries, the design patterns are followed. They are just common guidelines which will make your code more flexible and more maintainable. We will see the most basic design patterns which are most used in the world of computer science. First one, interpreter design pattern. Second, iterator pattern. Third, builder design pattern. Fourth, command design pattern. And the fifth one, observer design patterns. Now, what we will do? We will take each and every pattern and we will implement them into our electronic delivery app, electronic components delivery app. We will see how they are implemented and how they are so much useful for us. Interpreter design patterns. Now, what are interpreter design patterns? They are the patterns which help you to interpret an expression or evaluate an expression in a language. They are very much useful when used in the case of our electronic application, when we are using search queries. As discussed earlier, we have seen electronics menu model. Inside the electronics menu model, we have electronics app which is having a namespace electronics delivery app dot electronics delivery app mode 1. In this public class electronics menu model, we have one shop ID, public public string shop ID, which is expecting a string. After that, we have a private item ID. After that, we have item name. After that, we have rates. All are in public and private modes. After that, we are having iterator, the iterator class. Next class we have to see is the abstract expression C sharp file. In this abstract expression, what we are doing, we are adding the list of
all the items which the user has selected. Next one is the interpreter context class. All these are using the interpreter design pattern. See how are they using it. Inside this, we have this public interpreter context in which we are initializing the shop service to the new shop service which is getting selected by the user. After that, we have this location expression. While user can search from pin code or name of the shop or location, we have this list of all the shop locations which are selected by the user, which are initialized into this listed collection. After that, the result of shops which were relevant, we are throwing a query, SQL query related to it. Finally, we are checking whether we have got any result or not. The received result is finally sent back. How does it look from a client side? So same interpreter context is shown for the client side also. By default, the query expression is made null. After that, whatever query comes, it is being split, and whatever whatever results are retrieved is shown to the user. Let us see how this runs. It is asking for the location. When given Bangalore, it gives the list of all the items available in the shop. We have shop ID 001, which tells Arduino board. After that, we have resistor, diodes, IC7880 NAND gates, Raspberry Pi. What if I gave 004? 004 means I have selected IC7880 NAND gate for my stack. Now what if I have to continue? I will add 003. Yes, now I have added diode also. Now I am stopping my cart. So I can see that I have ordered two things which have got evaluated to total cost of 500 rupees.
Iterator patterns. They are mainly used in order to sequentially access and aggregate object items. I have used in this my application in order to access the electronic components when customer orders them in a sequence or in a set.
Next is the iterator pattern. We have seen in the outputs in the previous design patterns that we can add multiple things inside one of the cards. For example, in this, I have added multiple things into my cart 7780 Raspberry Pi. So, in order to add multiple parts, multiple lists into my object sequentially, we will be taking help of iterator pattern. How does iterator pattern work? So iterator pattern will find out the entire list and will make sure that each and every item which was there inside the list gets added to it. We have this create electronics menu iterator. What is this? This follows the iterator pattern. This is how things are working. We are from the electronics menu items, we are getting into electronics menu service, we are getting into electronics menu items, and that final stack of items is returned. This iterator is processing them and printing them one by one. It is all not only printing them, but it is printing the final bill, and it is also notifying the user what was the current status.
Observer design patterns. Imagine a situation when you have made a menu which has taken order from the user for delivering the electronic components. After taking the order, once the user is pressing the submit button, he is also getting notified that the delivery boy is on the way. How does this happen? One change at a time in one object, all the objects in the class automatically get notified about the same. For this, we use observer patterns.
Now let us see how this observer pattern works. When he is asking me for a location, I am adding Bangalore. When I did Bangalore, he shows me what is the list of items which is available inside the nearest shop. So after that, I am adding a NAND gate IC. Yes, I want to add one Raspberry Pi also. Now I want to clear out my stack. So he tells me my overall evaluation is 350 rupees. Now I will tell you what if I confirm this order. When I have confirmed this order, I got that my final address is my customer name, my mobile, my user ID and my address. Now what if I have to cancel the order? Whatever is my delivery status is notified to me as soon as I order or cancel the order. How is this done? How does one object comes to know what is the status of the other object? For this, we have the observer pattern. Let us see what is going inside the code. When we go inside the code, we come to know that the electronics delivery model is following the observer pattern. How does the order tracking driver works? It works upon threads. Threads are working, we are adding some orders, but after that we are notifying the other threads also to know about the same. Whatever is the selection, whatever is the latest object, we come to know what is the latest status of this object via the observer design pattern.
Next, we are having is command design pattern. Now imagine a situation when you are giving a command in the form wrapped up inside an object. Now that command can be used in many ways. It may be an order, it may be cancellation of that order. Now this order or this command design pattern will help you in order to hide that request so that the entire structure is not told to anyone and you can also deliver your order or cancel your order. This is how command pattern.
So as discussed, now we will see how our electronics app takes order and cancellation. As seen on the screen, we can see there is one electronics delivery app order and cancellation namespace. We have one class for public class cancel electronics. This cancel electronics class is initializing its members as shown. After that, it is running one execute function which is carrying out execution of the cancel electronics function via electronics object. So from the command iterator, So from the command design pattern, we can notice that two orders, whether it is placing the order or whether it is cancelling the order, can be placed via single design pattern. Okay, all this is possible only due to the command design pattern. We have this electronics menu item, we have order electronics which is getting executed, whatever order it is given. Where is the execute function? For cancelling, it is running the cancel electronics. For order, it is running for the order. Okay. So within one command, we are able to embed two orders of different type. First is placing the order. Second one is cancellation of the order.
Builder design patterns. So, builder design patterns are used at the places where you have to create and configure complex objects. What do I mean by complex objects? When you are adding things from different cards, when you are adding a resistor, when you are adding a Raspberry Pi board, or when you are adding some Wi-Fi devices, all the three come from different order stacks. Whenever in the case where you have more complex objects and you need to configure them, we will be using builder design patterns.
Next design pattern is the builder pattern. In the builder pattern, we have seen it allows us to add and configure the complex data types or complex objects into our list. So when we see how device.cs is implemented, we see that in the electronics items, uh, we are able to add any type of item singly and multiply. We can add a diode, we can add a Raspberry Pi, we can add anything that is inside the list. All these items are of different types. They belong to a different list, but then also being different, they can be added via the builder design pattern because it allows us to add all the complex and configure all the complex objects which can be added into the list. See what we are doing. We are preparing a device that is a new object to be added. After that, we are adding electronics item into it. Finally, we are printing the details of all the items that were added into the stack. Let us see how this runs. Let us see how the code is traversing. Inside this electronics delivery app, when we are doing show the code map, it is showing us. When double clicking upon this exe, it will show us how the things are linked. So this shows how our project is being linked amongst each other. Let us now see one by one how the observational pattern or how all the design patterns are implemented. Since it is already built, after that we will do the order and cancellation menu. We can see how things are getting linked. Next we will see the shop search module. How shop search modules is getting from order electronics to the electronics class to the cancellation. Next, we will see the electronics delivery class. It is being linked to each and every observational pattern, design patterns which are included in our project. This is the final class which shows how we have applied all the design patterns inside our project. Visual Studio provides us this functionality to see how inside the code project we have linked each and every design pattern.
We have seen implementations of all the design patterns. So, the conclusion is blindly following all the object-oriented practices, polymorphism, inheritance, abstraction, anything will not make your code extremely flexible and maintainable. But when we see our implementations, we have seen code has become much more flexible. It is maintainable. So we can say that if you follow all these design patterns, your code will be doing much better as in the past. Okay, so thank you and all the best for your application.